Hello. Today I'm going to talk to you about Chapter 5, Introduction to Valuation, the Time Value of Money. Our learning objectives: determine the future value of any investment made today, determine the present value of cash to be received at a future date, and find the return on an investment, and calculate how long it takes for an investment to reach a desired value. For instance, how long does it take an investment to double or something like that. And of course, for that, we use something called the rule of 72. We divide the interest rate by that. Okay, chapter outline: future value and compounding, present value and discounting, and then we'll talk more about present and future values later. So, one of the biggest basic problems faced by financial managers today is how to determine the value today of cash flows expected in the future or tomorrow. And the time value of money refers to the fact that a dollar in hand today is worth more than a dollar promised at some time within the future. And this is a really important concept. Future value refers to the amount an investment is worth after one or more periods. And the simplest case is a single period investment where you have $100 in a savings account and it pays 10% a year, if you're lucky. So how much would you have in that time period, or 1 year, if you had $100 in a savings account and it produced 10% interest? Well, formulas are equal 10%. 1 plus 0.10 equals $1.10. So the answer is you'd have $110 at the end of a 1 year period. Going back to the original $100 investment, what would you have after 2 years? So assuming the interest rate doesn't change, you have the original figure, which is 110, and then you multiply it by the 10%, and it's $11 in interest during the second year, and you add that to the original and the first year's interest, and you get $121. Compounding is the process of accumulating interest on an investment over time to earn more interest. Simply put, it's interest on top of interest, and that's why we call the result compound interest. And I use that figure all the time to represent compound interest. With simple interest, interest is earned only on the original principal amount invested. With compound interest, that's a little different. The general formula: future value equals $1 times, in parentheses, it would be the original amount plus the interest rate by the time period. So the expression 1 plus R over T is sometimes called the future value interest factor, or just future value factor, for $1 invested at R% for T periods. And it can be abbreviated FVIV R to RT. So going back to the original investment, what we have after 5 years, assuming the interest rate doesn't change. So by utilizing this formula, we get 1.6105, or $161.05 after 5 years. The future value of $100 at 10%, you have the years here: beginning amount, simple interest, compound, total earned interest, and ending amount here. Future values depend critically on the assumed interest rate, particularly for long-lived investments. And there are several ways of doing this. Number one, we could have multiplied 1.1 by itself 5 times, but that approach gets very tedious for, say, a 30-year investment where you have to do that 30 separate times. Calculators generally have a key labeled YX, and you could enter 1.1, press this key, enter 5, and then press the equal key to get the answer. You could also use a table that contains future value factors for some common interest rates and time periods, such as the one below. You can have this one, or you can get this on the internet. Calculated keys of particular interest: FV stands for future value, PV present value, IX/Y interest rate, and its number of periods. And things you need to do only once: make sure your calculator is set to display many decimal places. Set calculator to assume only one payment per period per year, and make sure your calculator is in end mode. Before you start, completely clear out the calculator and put a negative sign on cash outflows. Enter the rate correctly. This is the perfect form. This is for people who are using calculator keys. With the effect of compound interest, You've located an investment that pays 12% per year. Congratulations, because that's good interest. That rate sounds good to you. So you invest $400. How much will you have in 3 years? How much will you have in 7 years? At the end of 7 years, how much interest will you have earned? How much of that interest results from compounding? Based on our discussion, we can calculate the future value factor for 12% in 3 years as follows. Your $400 thus grows to $561.97. After 7 years, you'd have $884.27. Thus, you would more than double your money over 7 years. Because you invested $400, the interest in the $884.27 future value is $884.27 minus $400 is $484.27. At 12%, your investment earns 400 times 0.12 is equal to $48 in simple interest every year. Over 7 years, the simple interest thus totals 7 times 48, or 336. And the other 384 minus 27 is minus 336 equals 148.27, and that is the compounded interest of total. Present value when discounting. Present value is the current value of future cash flows discounted at an appropriate discount rate. Present value is the reverse of future value. Instead of compounding the money forward into the future, we discount it back to the present. To discount is to calculate the present value of some future amount. Present value of $1 to be received in one period is generally given as follows. Here's the formula for that. Single period. Suppose you need $400 to buy textbooks next year. You can earn 7% on your money. How much do you have to put up today? So we need to know the present value of $400 in year one at 7%. Proceeding as in the previous example, present value times 1.07 equals $400. We can now solve for the present value. Present value equals 400 times 1 over 107, that's 373.83. Thus, 373.83 is the present value. Again, this means that investing this amount 1 year at 7% will give you a future value of $400. Make sense? Yeah, I think so. Present value for multiple periods. The present value of $1 to be received T periods into the future at a discount rate of R is equal to this formula here. As the length of time until payment grows, present value declines. Present values and discount rates are inversely related. Quantity in brackets is often called the discount factor. And the discount rate is the rate used to calculate the present value of future cash flows. Quantity in brackets is called the present value interest factor, or just the present value factor for $1 at R% for T periods, and is sometimes abbreviated in the following manner. Calculating the present value of a future cash flow to determine its worth today is called discounted cash flow valuation. Suppose you need $1,000 in 3 years. You can earn 15% on your money. How much do you have to invest today to have $1,000? In other words, what is the present value of $1,000 in 3 years at 15%? We need to discount 1,000 back 3 periods at 15%. So the discount factor, 1 over 1 plus 0.15 to the third power equal 1 over 1.5209, or 0.6575. So present value equals 1,000 times 6575 is 657.52. How do we solve this on a financial calculator? Let's do that. The present value factor is the reciprocal of, that is, 1 divided by the future value. If we let future value sub t stand for the future value after t periods, the relationship between future value and present value can be written as one of the following. So that here on the chart. The final result above is called the basic present value equation. Evaluating investments. To give you an idea of how we'll be using present value and future values, consider the following simple investment. Your company proposes to buy an asset for $335. This investment is very safe. You would sell off the asset in 3 years for $400. You know you can invest the $335 elsewhere at 10% with very little risk. What do you think of the proposed investment? This is not a good investment. Why not? Because you can invest the $335 elsewhere at 10%. If you do, after 3 years, it will grow to $445.89. Because the proposed investment pays out only $400, it is not as good as other alternatives we have. Another way of seeing the same thing is to notice that the present value of $400 in 3 years at 10% is $353. This tells us that we have to invest only about $300 to get $400 in 3 years, not $335. And we'll take a look at this type of analysis later on. Determining the discount rate. We often need to determine what discount rate is implicit in an investment, and we can do so by looking at the basic present value equation. There are only 4 parts to this equation: the present value right here, the future value right here, the discount rate R, and the life of the investment T. Given any 3 of these, we can always find the 4th. You are considering a 1-year investment. If you put up $12.50, you will get back $13.50. What rate is this investment paying? So let's reverse this. First, in the single period case, the answer is fairly obvious. You are getting a total of $100 in addition to your $12.50. The implicit rate on this investment is thus 100 divided by $12.50 is 8%. More formally, from the basic present value equation, the present value is $12.50. The future value is $13.50. The time involved is 1 period. So we have this formula, and it's figured out to 8%. In this simple case, of course, there was no need to go through this calculation. But as we describe next, it gets a little harder with more than 1 period. Assume we are offered an investment that costs us $100 and will double our money in 8 years. To compare this to other investments, we'd like to know what discount rate, the rate of return, is implicit in these numbers. So present value is 100, future is 200, and an 8-year life. To calculate return, we write the basic present value equation. 100 equals $200 divided over 1 plus R with the 8-time period. It could also be written as this. We now need to solve for R, and there are 3 ways in which to do this. We can use a financial calculator, or solve the equation for 1 plus R by taking the 8th root of both sides, because this is the same thing as raising both sides to the power of 1/8 or 1.25. This is easy to do with the y x prime key in the calculator. Number 3, use a future value table. The future value factor after 8 years is equal to 2. If you look across the row corresponding to 8 periods in table A1, you will see that a future value factor of 2 corresponds to the 9% column, again implying that the return here is 9%. Solving for the discount rate. In his will, Benjamin Franklin gave 1,000 pounds sterling to Massachusetts and the city of Boston. He gave a like amount to Pennsylvania and the city of Philadelphia. After some legal wrangling, it was agreed that the money would be paid out in 1990, 200 years after Franklin's death. By the time the Pennsylvania bequest had grown to about $2 million, the Massachusetts request had grown to $4.5 million. If 1,000 pounds sterling was equivalent to $1,000, what rate of return did the 2 states earn? For Pennsylvania, there are 200 years involved, so we need to solve for R in the following way. And N is 200, PV is minus 1,000, future value is 2 million, solve for I over Y, 3.87. We would like to retire in 50 years as a millionaire. If you have a 10,000 today, what rate of return do you need to earn to achieve your goal? The future value is $1 million. Present value is 10,000. There are 50 years until payment. We need to calculate the unknown discount rate in the following. The future value factor is thus 100. You can verify that by the implicit rate. It's about 9.65%. Finding the number of periods. Suppose we are interested in purchasing an asset that costs $50,000. We currently have $25,000. If we can earn 12% on this $25,000, how long until we have the $50,000? Well, we can again manipulate the basic present value equation to solve for the number of periods. PV 25K, FV 50K, and I over Y 12%. Basic equation takes one of the following forms. We have a future value factor of 2 for a 12% rate, so we need to solve for T. For the table in A1, you see that future value factor of 1.9738 occurs at 6 periods. It will thus take us about 6 years. Waiting for Godot. You've been saving up to buy the Godot company. The total cost will be $10 million. You currently have about $2.3 million. If you can earn 5% on your money, how long will you have to wait? At 16%, how long must you wait? At 5%, you'll have to wait a long time, 30 years. At 16%, things a little better. You can verify yourself that it would take about 10 years. Summary of time value calculations. So in the symbols, our PV stands for present value. It's what future cash flows are worth today. FVT is future value and what cash flows are worth in the future. R is the interest rate. P is the number of periods. C is the cash amount. For future value of C invested at R% for T periods, these are the formula here, and present value of C to be received in T periods at R% per period, these are the formulas that are here. Thank you for listening.